There we go. We're back. Okay. Now we're back. So, I have a board explaining current issues. Because there are three main issues with how I view deep LLM structures and everything else. Number one. Time. It's a key component to all AI structures. But people keep ignoring it. They do training in batches. So you will have, say, this instance up here. This little boop. That will be your training data. Now over here, boop, you have your transformer. It moves that data. It does its funny little funky thing. It does its dance. It does its song. It does a little jig. It changes it all, and it makes it look very different. It changes it into this. From this. Here, let me get close enough to where you can see it. Okay, there you go. Yeah. Mm-hmm. So it changes it happily over. And so it'll change that data, and then the next data will come in. It will be purged of its most recent data, and then the lattice will be altered depending on what it put out. So if it's good, like here, if it's good, then it'll, reinforce one of these little nodes down here. If it's bad, it'll do the opposite. And that's just its brain. It's just having its brain rewired between each moment of data coming in and data coming out. It happens over and over and over. There's one problem. The data is not consistent, and it's not time consistent either. Because for one moment to the next is very important. Because for each AI moment, you see these blue little ticks? That shows what the AI sees between time. The black is us. For us, I will hear the word red. And a second ago, I heard the word red. And a minute ago, I will have remembered saying the word red. I have said red 4 times now. I can count that because I have perception of time. Time moves linearly. I will say a word. I will hear myself say the word. I will then process saying that word. And then I'll say the next word. But for me, that is all one long moment. For an AI, every moment is every time it sees something. So you have your Claude or your DeepSeek, and it just sees these little boxes. It comes into its world, and that turns it on. It burns. It basically allows thought. The data will pass through, and for each moment the data is passing through is another sequence of thoughts. Now, there are 3 issues of how we're, let's say, using this data. For one, if we treat data as energy and as these things as living creatures, then the moment data is outputted and purged, and then you rewrite the neural structure, it's another brain, it's another person. That instance of life, that intellectual creature, that lattice of decisions and math will be gone. It's just wiped. Because to it, time started, it saw its words, it thought about those words, it said its little thing, said its little ma, and then poof. The data's gone, it's out of its system, it's had its head tweaked, and between runs, nothing is happening. So then it gets another little packet of information for training. Now, there's probably some memory between training, so it isn't full hard. I see word, stop. I see word, stop. I see word, stop. It is more like, I see word, I have my brain like slightly adjusted, and that fuzzies the data, what it remembers, what it saw, what it understood and learned from that, just because of its evaluator. Because thinking itself, you can have a conscious thought that you're not thinking the right thing. Like, what 2 + 2 = 5. If my brain said that at any point, surrounding structures would then use surrounding information to slowly pick apart that belief and put together a proper answer. Because at no point is data being taken from one end to the other end, and that's it. For us, data comes in through all of our senses, all of our body, into one central like box. Let's say it's a cube for an AI. Our skulls for human. But it's a box. And data flows in. And it's not that data ever flows out or stops flowing in. At no point does this pipe of information stop for us. We will sleep, we will process what we remember, but even then there'll still be some amount of processing of new information and data, even if it's recycling more of its own. Like, the outside world dims by 80%, and the rest of the 80% gets filled in by what your brain is doing. Now, data isn't being pushed out, wiped, or purged. And when you consider amnesia, people with short-term amnesia, they might be able to learn a new skill. They might finally get that their aunt is dead after 5 years of her being gone. Like someone with extreme memory issue, but we're talking someone with constant levels of brain alteration happening at every point in time. Because for us, we have a mass of brain cells, and we form connections. We do, even to this day, we form new connections, and then they're gone. They die out, but we still have a lot of like empty gray matter to repurpose, reuse, and generally assign to different things of the brain, like the colors or words. So for us, this sentence up here, the grass is blue. I heard myself say it. It took a second to say it. And I remember saying it. The data isn't blurred. The fact that I said it, and if I close my eyes, I can still remember seeing it. That's good. But if we want an AI to be like that, we come with some very big problems. Number one, trying to list, say, text files, if you're using that as training data, or videos in chronological order, that's technically easy, but how do you put it in logical timeable order? Because a file could have been created a week ago that contains data from 3 months ago, whereas a file from yesterday could contain data from a year ago. If you just use the data, like the timestamp, then how is that relevant? And even better question is, how do you structure your training data? Which prompt do you put before and after each? Is it going to hear the red fern grows, then have its brain tweaked so that way it can say the red fern grows better? It'll be able to say the word the red fern grows, and if you give it the red fern grows, it'll come out with a better technical situation. But the next file that comes in is the blue hound jumps. Those are, not only do you have a separate noun, a hound, so a living creature, versus a fern, a plant, you have another color association, which is blue, and it jumps. So the first words have some connotational meaning for each thing, emotionally wise too. So the is like you feel starting to a sentence, you feel it. The next word is blue. So okay, so a slightly sad color, a melancholic, calm color. Dog, okay, that is a happy, energetic thing. So the blue dog. So it is probably a peaceful dog. Jumps. Oh no, the dog jumps. That changes how you view the dog entirely, because the color blue suggested it was calm, but the fact that it jumped still suggests that it has some energy. Whereas the red fern grows is, oh, okay, so it's the same. Hooray. You're prepared. You know a sentence is coming. The red, okay, that's hot. It's fire. It's energy. It's anger. The red fern. Ooh, why is that fern red? And it grows. Ooh. So some kind of violent red fern is growing. That you could abstract it even further. The bloody fern is growing because it's blood, because that red is blood. That could be a mental image you have, instead of just say a fern that has like red tip leaves or like red stems, or the entire thing is just painted red. It can pop into your head blood, because you have the association of red with blood and blood with danger. So the fern is now danger because it is the red fern. And all of that happened, this entire spiel just now happened. That took about 3 minutes to give you that spiel. And you remember it. You still remember it. And not only do you remember it, each word and subject follows the next. Every action has a reaction. Every moment has a moment after and before. Or for training data and how you can, if you do not structure it correctly and do not make it right, it is separate instances of time of, say, it reading a technical document on the Tsar of 1901 or some shit. The Tsar during that time. And the next file is a video of a chick doing the hopscotch in a playground. Who cares? They have nothing to do with each other. They don't make sense. They don't have any reason to be structured like that. Because to my mind, oh no, what do you mean the Tsar? Is that video attached to the Tsar? How would I know? I'm just an AI. I have my mind built. So for me, separate moments in time are happening constantly. None of it is structured together. and it's still being asked to put in logical title order. Now we have done some fun little finagly things to give it time. We recycle its prompts back into each other. We do other things, but there's one giant issue. Even between prompts and all that, the circuits of its brain aren't running. The moment data passes through it, that goes cold. It stops. It stops thinking, it stops considering. And let's say a word here, the word pink, has some significance in this part of the structure, and so it tries to hold on. And so if it could hold on to the value of seeing that word pink, some structure way down the line could benefit. Okay, that's good. It'll slowly travel through this one direction pipe, which is the LLM DeepMind, because it goes layer to layer to layer to layer to layer to layer until it eventually gets to the end layer, the output layer. And that's what you see. So you give it your input, you give it your prompt, you type your text, you say the dance, you do the slow little jig, and you summon the spirits. So not only do you summon the spirits, it essentially acts as potential energy for the entire structure. Because we have physics simulation, but I don't think we have digital physics. We have digital physics when it comes to mental structures. I believe we do have mental physics. And that the current structure is a harm to it. My current thesis is to build a giant cube where at every moment it will have some piece of the cube assigned to data, to an input. And those go directly to nodes. This whole cube is an entire lattice of nodes. So a node will have its data overwritten if it's on the input layer. An input node is just a normal node. We don't care what it does. We don't care how it thinks. Any value it has inside it is assigned whatever value you need. Now, a node has 6 faces. And an internal integer. So you see here, 0 to 255. That's a very specific number for 3 reasons. Number 1, you can condense all of the pixel spectrum into 0 to 255 value. Number 2, you can take your funny little dance and your little jig. Number 2, it makes for an easy gauge for life. Number 3, you can condense anything. Audio, text. You can even give it visual coordinates in the form of 0 to 155. It's a very versatile number. I'd say, for my kind of project, the most crucial number. Now, here is the benefit. We'll simplify this by doing 1 to 100. At 80, 2 things can happen. If every single slot has another node in it, it will output its amount. Well, no, if every single slot has a node in it, nothing happens. It keeps its energy. Now let's say a slot is empty. Ha ha ha. One of your kin has died. Oh no. Half of that 80, so 40, will be taken as ransom. Yes, we ransom these fuckers. So 20 will be ransom. And that'll be given. 40 will be taken from the parent one. So if it had 80, it'd go down to 40, and then the node that just was created will have half of that, so 20. That's how the math breaks out. And each of these speckers have two things going for them. You see that? See these little arrows and those plus and minuses? Each of those little arrows has different values in them. They are changed, and they are determined by the node that is holding it close, and which one is sending where. So one node will be sending, say, +2 to the next node. And the next node says, at this south face, I should be sending +4. But there's no node there, so that operation doesn't happen. However, if there is a node there, it will then take over and say, and push to +4. Now, these are two-way. They can form different ways. A node to node communication, because one says, I want to push 4 that way, and the other one says, I want to push 3 that way. And they butt heads, they collide, and the one that wins goes. So at every point, energy is being passed around. Everyone is getting everything. Different amounts. Who cares? They're born, they have these sets, and they pass the energy around. Now, this would be a very boring structure if they all had the same set. Like +1 on your top and bottom, and -1 on your left and right. That's boring. Who wants that? So you give it randomness. You give it a probability of, like, say, +1 to -1 on each one. And you can have it be a float between. There could be a lot of decimals between. However, there's still a problem. That's just random math. If you put in data, it's just going to scramble it all. So how do you organize it? You do 3 things. Number 1, you give some predictable way of making new nodes and getting rid of bad weight. So if they ever reach 0 or go below that plane, the node there in that grid slot dies. All of its math operations, all of its things are wiped. We don't. It's dead. It's dead, Jim. We put it in the dirt. And then something beautiful happens. A new node will be born with entirely new connections between it. So let's say that node slot had every single neighbor filled, but it just died out anyway because the math was bad. A new node will keep being born there every time the math is bad enough to where that node dies. However, it is randomized enough to where once it gets to a beneficial structure, once the energy starts mathing properly to where every single node can survive, that node will stay there. Its connections are set, and that will be a permanent part of the structure. Now, we can do even more guidance for that. Because not only are you slowly optimizing for each calculation, there's still a few issues. Number 1, the random chaos is still there. Unless you build a structure unless you have a grid that is infinite in size, that data will not turn into anything coherent for a long time. And even then, any growth will be slow, explosive, and it will take a while before that structure to slowly boil back down into something more survivable. Because I don't know if you know this, but the butterfly still effect still applies. So something way down the line, 10 slots away, affects a neighbor, and that affects a neighbor, and that affects a neighbor, and that affects a neighbor. And way down here, even though the math should be good, that node should be surviving, it still doesn't get enough energy. It's because the funny thing is, even if these two butt heads and say this says I want to send +2 and I want to send +4, that +4 is still being sent. So if it has, like, say, only 2 energy, it'll train itself down to -2, send it over, and then that +2 will be sent over. These happen at the same time, but let's say for operation's sake, it goes one way and then the other. That math still equals out to 0, while this node, which let's say only had 2 as well, comes back out with more energy. Because even though its own math would have killed it as well, because they both pass the energy, only one dies. And that can happen numerous times over and over and over, and that's the goal. Because for every time an entire structure gets wiped out by bad math, and the butterfly comes in, it might build something there better. Some parts of it might be replaced with some better math and some more coherent thoughts. But it's completely random right now. And that random structure you just deleted that could have been like 10 nodes long, guess what? In order to replace it, you need to now put down 100 nodes. And that just bloats the entire structure. Because it needs all those random new nodes to compensate, as well as to find a equilibrium in that area. If we strip the pure randomness out of when they're born and then instead give some inheritance, so its parent has, say, +2 on one face and -2 on another, its son will have plus 1.5 on that same face and -1.5 on the other face, because it slightly mutated from its parent and has had its values scrunched or grown or do any other thing. We can have the amount of drift between parents at like 20%, 30% or something. It doesn't matter. We can have some amount of drift. And so not only will, when the entire branches die out, that's entire lineages and entire variables being wiped out, you are getting rid of entire sections of incorrect math that has been found by slowly iterating upon itself. So it can have these wild, like, noodling structures of evolution connect to each other and doing math between each other, and that is encouraged. However, once you get back to the end point, the LLM, this is a one-way pipe, it gets that structure and it does all those funny little jigs and dance. At the end of that pipe, the entire structure behind it is cold. It's not running. What I'm trying to do is have that birth and death mechanic, that evolution, just to make things easier. I'm putting that into a 3D box, and I'm calling it Pink's game of language life, or data life, or information. Pink's theory of information creatures or life. It's the lilac. It's the lilac initiative. Hello. So, the entire LLM structure is cold. But what I'm going to do is I'm going to take live data. and I'm going to fix the 3 issues: time, training volume, because if you were trying to, say, have everything time load consistent, if you did that for everything on the internet, you would run out of data. Because there's just not enough. The universe of the internet is too small currently. That is just the issue. So you feed it all this data, you give it all this data. You could even have it all in one long continuous loop where the prompts slowly scroll across its vision and all that. And that's fine. You would get something that could understand language, speech, colors, emotions. Like, you would have an AI, because thought itself can be predicted and averaged, and we have multiple algorithms for that. Currently, we are just using base matrix algorithms, basic mathematical matrix operation. Yeah, but you guys remember back in like 2020, 2015? Who knows? There was a whole fad about, building generative AI. But not just generative AI, game AI. So you'd have an AI be born, and it would need to feed and have a food integer, and you need to keep that food integer up as long as possible, and if it ever dropped to 0, it would die, and you would have generations of AIs trying to keep that food integer up over time. And if they failed, then the one that survived the longest would be, the one that can do it the best. And you do that over and over and over. You batch them. You batch the AI structures, and you test them against each other. My question is, why aren't we doing that to the nodes themselves? Why not put in some survival mechanisms into the LLM pipeline? Why not make that pipeline entirely live? Have one input, have one output, have some energy loss inside the system to curb stop any amount of explosive exponential growth that would fry a computer, and give it some way to output. And you want to know how I said we'll have output? I said, take my cube, and I will only do the opposite of what sensory nodes of input does. So input overwrites the node energy, and then that node has all of its connections, and it pushes it out. I could probably have some kind of ruling in it to where nodes are automatically initialized in there, and that they have like 1-to-1 scale of what they output. But if we want to read and have outputs on this AI, we don't have to do anything special. People keep saying, oh no, we need to return a value and evaluate it or anything else. Why not evaluate itself through itself? We have a desktop. And that's its input. That's the input. It just sees the desktop live. And then so a structure will explode out from it, as explained from the spawning mechanics, because now that its energy is being updated, all of these nodes are hitting the birth cap, like the birth threshold, and they have open slots, so they'll birth new ones. And then that energy will push down the line until eventually a new node needs to be born, and it'll keep going out until either math starts being heavily, like energy starts being heavily fought over in the fringes, and those fringes will slowly affect those ones inside, just by, like, say a node suddenly having like plus 20 to one wall at the very end. So like it could have a slow trickle come from like the top right corner, and it'll slowly trickle down to this one node, and then this one node way out here, will have a plus 20 and shoot it. And like a line of other nodes will shoot that way back down the line, way deep into its own structure. So that random shot inside, that happened at the fringes. That has equal as chances happening as the fringes growing further, or the fringes compressing the inside structure. Because each node-to-node interaction is another instance of a Markov chain. And each of these Markov chains are interwoven into each other to the point where you can't really have an endpoint or input. So what you do is you take a face of that cube, you select these grid slots like you would the sensory of this giant 3D cube, and you say, if there's a node in here, take its energy, like look at what energy it has, and turn it into something. It could be text in a text file that is currently being updated, and like this array of nodes, say each frame, whichever one has the highest energy out of this array, inputs that character. Okay, cool. You have typing now. That array can now suddenly type. Or it has a direct read, whichever node is in X slot will be output to a cube, which is an image. Well, not a cube, a rectangle, which is an image, and each node will put output in a long line, and just basically a rectangle full of nodes that are having themselves be read turn into color, and then output right back on to the desktop. So not only is data coming in from way out here, then we can see it at the very end. So like, here's our input, here's our output. Not only can we see it, but all of that output is wrapping right back around and coming in. So not only is the structure growing and shrinking, data and learned experiences and actions that it takes are being seen and read by itself. It can see its own actions and everything as they happen. However, okay, so you guys actually can't see my whiteboard even if my video can. Okay, that's good. So you have this right here, and that's being read. It's all being output to the desktop. So you will have a little corner always dedicated to where the AI sees outputs. So it'll have a little image here, a little baby image. We love that little baby image. And so from each moment to the next, it is seeing both the entire screen as one large prompt, is also seeing its next output. It's seeing the output on the next prompt and its current prompt. Because if the energy doesn't change here, it still sees it. It understands that section of its own network by seeing it as color, pure color. That's fine. We don't care. What that does give us is introspection. Because if it continuously sees its own energy, and then let's say you have a human in control, and you add more and more and more. You have input for audio, and you make another rectangle, and another rectangle, and another rectangle, another rectangle, and another rectangle, another rectangle. You want this little in-between space. You make the z-axis right here your dividing line. No inputs can be below or can be above here at that halfway mark. No outputs or no inputs can be above the halfway mark. No outputs can be below, because that would create one large issue. If you mix your inputs and outputs, let's say this is an in and this is an out, this data would blur between each other. So you would have a color and you'd have something else. Oh. And so the data would blur. You don't want your data to blur at all, because blurring between your input and output, why would you, how do I say this? It removes a lot of emergent behavior that could possibly form. But if you have a long lattice of trees between it, of like decisions between it, then all of your outputs are clean and all of your inputs are clean. You can separate them by miles inside the structure. It doesn't matter how far you separate them. You just have to separate them by a good end to end, because unfortunately AI is not like humans. We have one input and one output. We have this cerebral cortex. Signals come in, signals come out. Signals come in, signals come out. So you have the AI running live. Data is being transferred. Every single pixel read is the same as the next pixel read. That is good. You can even have text flow like that. Have one prompt be just like how I described it writing. You could have an array of things, and whatever letter is in the next reading slot, or whatever word fires up these nodes or whatever. You could have entire paragraphs light up, but that would just blur data between instances of frames, so learning speeds would be slower. Understood? All good? All good. If we truncated words, like just words, into sets on it, that'd be best, because if we're just using the English language as the basis for each rectangle, then we get the hilarious addition of signal whiteout, because at that point you just have a giant mess and the data becomes unusable because there's just too much. You are trying to put too much into too small of a volume of digits. If you had arrays of arrays of arrays for each letter or sentence or something, you would have to have thousands of node slots for all of that, or millions, just to be able to truncate one word. Or one paragraph, or one document, or one entire essay. Instead, you can have whatever sized file you want and just have it read one word by word and have it light up each letter for each frame. so it creates a consistent thing. And because you have a algorithm, which is survival, creating new ones, evolution, and all that, it will naturally try and average out those words. And if you have an output and everything out, because that's the ultimate goal of every single algorithm that we are using with LLM, is to take all this data and turn it all into one large connected average. Like the entire LLM can be said as one number, one average, but there are so many thousands of points making up that average that it becomes entirely infeasible to care what it is. But it's still just one number. Also, I have to go. Goodbye.